Hi, my dear students. In last couple of weeks, we were discussing about dynamic econometric models. Dynamic econometric model, as I told you, is a model in which the lagged values of either dependent or independent variable is appearing as an additional explanatory variable. When we have such a dynamic econometric models, the usual Euler's procedure may not appropriate due to certain problem associated with this kind of models. The major problem with this dynamic econometric model is if we apply Euler's to these models, we will get the result, but the result will be biased as well as it will be inconsistent. Okay. Yes. So in this chapter, we have also discussed how we can overcome this issue by introducing Koyak models, then adaptive expectation and partial adjustment model. Then we introduced instrumental variable method, and finally we discussed Allman's polynomial distributed lag models. Okay, and one more topic left in that is Granger causality test or causality. Okay, so causality is basically uh, a time series method. Okay, so it will be discussed in the time series chapter or the last the fourth chapter. Okay, so what we are doing now is we are coming to the first chapter. Okay, so first we discussed or we completed second chapter. Okay, now we are moving to the first chapter. It is a chapter on simultaneous equation model. Okay, so in when we know this, when we hear the name of the simultaneous equation models, okay, it is not the simultaneous equation model as you have learned in your mathematics. Okay, you might have learned how to solve how to solve a simultaneous equation with two unknowns and three unknowns in your mathematics course. Okay, so this is not that simultaneous equation. Still, this is the simultaneous equation, but not that we understood in mathematics. Okay, it is somewhat different. Okay, so in basic econometric courses until now we were discussing about single equation models. Okay, we discussed single equation model, or we were discussing about uh, a relationship that is described in a single equations. Y is a function of x. Y is equal to alpha plus or beta 0 plus beta 1 x plus u. This is what is called a single equation model. Consumption is a function of income, single equation model. Okay. In this model, our aim was to estimate the average value of y conditional upon the fixed values of x. Okay. And this type of a relationship assume that the cause and effect relationship is unidirectional and it runs from x to y. Okay, so in all this model what we assume that the cause and effect in each regression equation there will be one cause and one effect. Cause is what is called independent variable and effect is what is called dependent variable. Okay, and what we assume that this cause and effect relationship is unidirectional, that is x will influence y, x will influence y and y will not influence x. Okay, yes, that is the explanatory variable is the cause and the dependent variable is the effect. Okay, so this is what is called in single equation type models. Okay, so what we have discussed so far is this type of a single equation models. Okay, but the problem is in many situations, especially in macroeconomics, one way or unidirectional cause and effect relationship is not meaningful. Okay, so in many situations we need more than one equations to describe a phenomenon. Okay, so for example, you look at an example. This is the Simultaneous macroeconomic model. You all already learned these things. Okay, CT is equal to beta 0 plus beta 1 yt plus ut, and yt is equal to ct plus it plus gt. Look at this equations. Yt is depends sorry ct is depends on yt in the first equations. Look at this equation. Ct is a function of yt. Okay, this is the first equation. And look at the second equation. Yt is also depends on ct, it, and gt. This is what is called bidirectional relationships. In first equation, ct depends on yt, and in second equation, yt is depends on ct, and these both equations are simultaneous equations. Okay, ct is a function of yt, and yt is a function of consumption, investment, and government expenditure. Okay, so this is the example of a two-way equation or simultaneous equations. Okay, and in this equations, what we are assuming that there is a two-way or simultaneous relationship, and y is determined by the x, and some of the x are interdetermined by y. Y depends on x, and x is also depends on y. Okay, so this is what is called a simultaneous equation model. Now, what is the problem with this model? In this type of a simultaneous equation model, we cannot estimate the parameters of a single equation without taking into account the information provided in the second equation. Okay, so in this type of model, what's the problem? We have two equations. Suppose if you want to estimate the first equation, you have to take into consider the second equation. And if you want to estimate the second equation, you have to consider the first equations. So you have to consider this both equation as a system of equation or simultaneous equations. Okay. So even if we have interested in one equation, we have to consider the other equations. Okay. So without considering the one equation, we cannot estimate the other equations. That's the problem with simultaneous equation model. Okay. So what is a simultaneous equation model, or what is a simultaneous equation? A model in which there are more than one equation for each interdependent or mutually dependent or endogenous variable is called simultaneous equation model. Okay, that means if you look at this equation, ct is a function of yt, yt is a function of ct. Okay, so we have two endogenous variable or two dependent variable, and these ct and yt are two dependent variable in two equation, but they are mutually interdependent. Okay, that's why it is called endogenous. Okay, so we have more than one equation for each interdependent variable. That is called a simultaneous equation model. Okay, now using a graph, I can tell you what is basically the difference between simultaneous equation model and a single equation model. Look at a single equation model. You can see that the arrow is coming from y to c. What is that? Yt influencing ct. income is a factor of, income is the determinant of consumption. Okay, and not only the income, there are some other factors that will also affect consumption. Okay, yes. So here we have a one-way relationship. One arrow is going from YT to CT, and from error terms to CT also one arrow is going. Okay, now you look at the second equation. This equation, here we are having CT, ET, YT and IT. CT is the dependent variable, epsilon T is the error term, YT is the uh, it may be dependent variable or independent variable or IT. Okay, so here what's the problem? This investment is influencing income. Okay, similarly all other omitted variable or epsilon T is also influencing consumption. Okay, but here look at this equation. Here CT is influencing YT and YT is also influencing CT. Okay, so here we have a two-way directional relation between CT and YT, and CT and YT are two dependent variable in two equation. Okay, but when you take CT, YT will appear as a explanatory variable, and when you take YT, then CT is also appearing as an explanatory variable. So CT and YT are mutually determined or endogenous variable. Okay, so this is what is called a simultaneous equation model, and this is what we called single equation model. Okay, yes. Now let me give you some examples. Okay, so this is the pure microeconomic models, market determinations. Quantity demanded for a commodity is depends on price, income and some other terms or other factors. Okay, where alpha 2 is negative. Okay, because demand equation. Okay, the second one is quantity supply is price, raw material price and other factors, where the relationship is positive, that is supply function. Okay, so we have two equations here. One is demand equation, one is supply equations. Okay, then there is a condition. What's the condition? QS is equal to QD, where the price is determined. Okay, so in all equations the price is the factors, and what is the price? The price is determined at the point where quantity demanded is equal to quantity supplied. Okay, so in this model, how many equations we are having? We are having one demand equations, one supply equations, and there is a link between this demand and supply equations, because the price factor is, or the variable price is appearing in both equations as independent variables, and the link that connect between price and quantity and price and quantity supplied is a condition. The condition is QS is always equal to QD, where the price is determined. Now you look at the macroeconomic model, Phillips curve model, Phillips model. Okay, here WT, wage, is a function of unemployment and price level. Wage is a function of unemployment and market price or general price level, and this general price level is equal to wage rate, interest rate and money supply. Look at this equation. This WT, wage, depends on price, and price is also depends on wage. Okay, so W depends on P P depends on W. There is a mutual dependence between these two equations. Okay, so if we want to estimate the first equation, we have to consider the second equation. Okay, now you look at the simple macroeconomic model. Okay, money supply is depends on GDP. Okay, M is a function of YT and YT is a function of M and I. Money is a function of YT and YT is a function of money and investment. Okay, this is one of the simple macroeconomic of Keynes. Okay, so here also what we can see that this M and YT are jointly determined variables. Okay, yes. So these are some of the example of simultaneous equation model. Now, what's the problem with this type of model? Okay, so you consider a simple Keynesian model of income determinations. Consumption is a function of YT and UT, and YT is equal to CT plus IT plus GT. All of you have learned these equations. Okay, all these relations. Now, C and Y are interdependent. C and Y are interdependent. And what we have assumed in our oilless assumptions, this YT and UT is a stochastic error terms, YT is the explanatory variable, and there should not be any relationship between this YT and UT. Okay, yes. But what will happen? This UT will influence CT. Okay, and because of this CT will also influence YT. Okay, so UT will influence CT, and since this effect of UT is there in CT will also influence YT, then this UT and YT will be related. Okay, since UT will influence CT, okay, CT will influence YT, and because of this factor, CT, YT and UT are related with each other. So what's the problem? It violates one of the fundamental assumptions of oilless, that explanatory variable and error terms are unrelated. Okay, so this is the problem with this simultaneous equation model. Now, yeah, so yes, okay, so this is today's discussion, and tomorrow we will come to the it's the next level. Okay, so what we have discussed so far is, from our basic econometric course to till we discussed single equation models, where we will have only one equation. Okay, but in many macroeconomics and microeconomic models, there will be more than two equations, or there will be more than one equations, and there will be some connection between these two equations. Okay, so such equation is known as simultaneous equation model. The problem with this type of model is, if we want to measure, if we want to estimate the parameters of one equation, we have to consider the other equations. Okay, so if we are not considering the other equations, and if we estimate the first equations, then whatever the result we obtain will be problematic or wrong, because it's violate one of the assumptions of oilless, that explanatory variable and YTs are, sorry, explanatory variable and UT should be unrelated. But when we have a simultaneous equation models, UT and independent UT will influence independent variables. Okay, But in second equations, this uh, the dependent variable in the first equation will influence the dependent variable in the second equation, and thereby the dependent variable, independent variable, and error terms both will be related with each other, and it violates the one of the assumptions of OLS. Okay? Yes. Yeah. Okay. Thank you. Then tomorrow we will discuss the next one.